Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Alright, grade 9. So what we're going to be doing today is looking at electric cells as energy systems. Okay, it's following on from forces, which we had a look at previously. In the last force we learned before we closed that chapter was, of course, electrostatic force. We learned about thunder and lightning, or more so about lightning. We did a little bit of an activity last week. We went through some revision for you guys before the tests and stuff, which I'll ask about in just a moment. But what we're going to discuss today is electric cells as energy system. Going forward in this topic, we're going to have a look at three branches. Okay, one, we're just going to have a look at a cell is a system on its own. A cell is also a source of electricity, or cells are sources of electricity as well. And then we're going to look at, of course, to bring it all home, at a battery, and we're going to find out that a battery actually is a group of cells that are connected together. Okay, so first things we're going to do is we're going to have a look at electric cells going to start off with. Okay, look at how we can make one, and have a look at how we can make a cell using a fruit. Okay, and which is quite interesting. If you have this fruit at home, which I'll get to a little bit later on, and some connecting wire, you're more than welcome to try the experiment. Right, electric cells. Now, one thing we must understand is that a cell is a chemical source of energy. Alright, so put that down there. It's a chemical source of energy, number one. Now, what does a chemical source of energy imply, or what does it mean? Okay, it implies or means it's a power source. Okay, something has power, it has energy. Okay, as we get into the more senior grades, we get a formula for power. That power is equal to W divided by the change in time. W stands for work done, which means energy. So if something has power, it has to do with energy. It has energy to dissipate or to give. Okay, but that's for future reference, of course. Those of us that's going to continue our science journey, some of us will not, and that's okay. Now, inside all the cells, there are chemicals that will react, all right, to separate positively and negatively charged ions. Okay, so we get two different types of ions. Okay, so the chemicals will react to either positive or negative charged ions. Okay, now the cell does provide an excess of negatively charged ions on the negative terminal, and the positive terminal will obviously provide an excess of positively charged ions. If you think of a car battery or even a normal battery, I have a wireless mouse right now. So if I even take out the battery of the wireless mouse, right, which I've just done here, the top part is positive, the bottom half is obviously the negative side. Okay, so at the positive end of the little cell here, or battery, I'll obviously find my positively charged ions, and at the bottom would obviously be the negative, right, for the negatively charged ions. Okay, so I'm just going to put my battery back in. Alright, there we go. It's working again. Fantastic. Okay. I need to erase this little dot here. It's throwing me off a little bit. There we go. Okay. So that's just explaining the battery. Okay. So some may be asking, what are ions? If I could just explain that maybe as a separate note here. Okay. Reminder, what are ions? They are electrically charged. Okay. Electrically charged atoms or groups of atoms. Alright, those are what ions are. Okay, Now, I do believe in grade 8, you learnt that a circuit is a system for transferring energy. Okay, so let's just add that as a little bit of a revision note here for some of us. Okay, circuit is a system for transferring, not transporting, but transferring energy. Okay, that's what a circuit is. Okay, now what I'm going to do is I'm just going to draw a type of chemical cell, all right, for you all. Okay, I'm going to demonstrate it, and then I'm also going to aim to explain it. Okay, let's just go draw that quickly. All right, so here we have a drawing. Okay, so first drawing that we have here is of a little chemical system, or a cell or electrical cell of some sort. Okay, here we have a zinc electrode, which will be known as the zinc anode. Okay, and over here we have copper, but this will be called the copper cathode. Okay, that's a T over there, copper cathode. Okay, so from this figure, we can see that there's a series of events that's leading to some sort of movement of electrons that's happening inside the cell. Because as you can see, we got no battery. All right, we have absolutely no battery. Okay, we got no plug switch or anything. All we got is two metals linked up with some type of connecting wire into oh, it's one thing I forgot to label. This is called a porous disk. Okay, a porous disk. Okay, it's linked to some type of liquid substance, some type of aqueous solution here. Water, or this looks like water, and this might look like some electrolyte or whatever. And of course, electrons are now flowing and are lighting up the light bulb. Okay, basically what this cell proves, it proves this fact that as chemicals react, inside the cell, okay, an electric current begins to flow. Okay. Now, what is an electric current? It's the next thing that we need to uncover, okay, which I don't have space for, okay? But electric current, okay, is what I'm actually going to put on the next page, okay? But I'll introduce it now quickly, is that an electric current is the movement of electrons from positive to negative, all right? So in this case, it'll go from a positive pole to the negative pole. Okay, so all right, so in the drawing previously, okay, the bulb did light up. Okay, I just didn't draw the yellow thing around it because you wouldn't necessarily do that. The cell obviously provides energy, which is therefore carried to the light bulb. Okay, and when that energy is transferred to the light bulb, okay, so there's an energy transfer. To the light bulb, okay, when that happens, okay, we can definitely see that energy transfer because there is work done, all right, by heating the light bulb filament. Okay, heating the light bulb filament. Okay, and when the the light bulb filament is lit, is lit obviously, or it lights up, it glows. Okay, it glows, it shines. Okay, the electrons are then carried back to the cell, where they are supplied more energy, and then they repeat the process. Okay, this process will obviously repeat until the filament can no longer withstand the heat, and then it obviously burns out. All right, in that case, you just change the light bulb. Okay, that energy, all right, that the cell contains, okay, is called chemical potential energy. Okay, so a cell contains chemical potential energy. Okay, now I'll explain what chemical potential energy means. Okay, we all heard the term before. Hey, you got so much potential. If you haven't heard it from anyone before, you do now, or you have now. Okay, you got so much potential energy. Potential energy, or potential, means it's stored on the inside. Okay, so this is what it can do. Okay, it can do this, or it can do that. Okay, so it can hold, it can supply so much joules of energy, because energy is measured in joules. That's what potential energy means. It's stored up energy. Okay, just so that we all understand what this word potential means. Okay, we all know it's chemical, but now that we understand what potential means. Okay. One thing I want to definitely go through now is just have a look at the pole quickly. Okay, now a pole, or in the case here, we actually had a plate of metal. Over here, we had a metal plate, a pole or a plate. Okay, is a conductor. All right. Now, what happens with a conductor? Okay, a conductor allows electric current to flow through it. So, an example of that, okay, would be a battery or an electrolytic cell, which obviously that pole or plate, being a conductor, can either allow the electrons to flow, which means enter, as well as leave the cell or the electrical device, right, such as a battery or electrolytic cell. Okay, now the plates of a battery they are usually separated by a solution that does in fact contains ions. Okay, let's add that to our notes. Let me just show you here that obviously this little solution like lines here on top here do obviously suggest that there's a solution here. So the plates of a battery, or in this case the two plates of the different types of metal, they are separated by a solution, and in either of these solutions, of course, they do contain, the solutions rather contain ions. Okay, the negative plate undergoes a chemical reaction that gives it excess electrons. Okay, so let's add that here. We all know that there's positive plates and negative plates, or positive sides and negative sides to our batteries. A negative plate or pole. Okay, the reaction takes place here. Takes place that leaves it with excess electrons. Okay, now electrons are negative. Okay, the positive plate does the same thing. Okay, it's the same thing. Okay, for the most part. Okay, but it undergoes a chemical reaction. Okay, that instead removes electrons. Okay, so for the positive plate, the reaction takes place that removes electrons. Okay, so this part is only the same. On the negative plate, or the negative pole, the reaction that it undergoes is that it gives it excess electrons. Okay, now when the two plates are connected by external electrical circuit, the excess electrons flow from the negative to the positive side. Alright, so we've been talking about a battery, and we've mentioned the battery for a long time, but let me just explain what a battery is. Okay, now a battery is a group of cells. Okay, battery is a group of cells connected together, okay, to form one big energy source or power source. Okay, so if you have a look, of course, at a car battery, there's a number of plates in an electrolyte solution. Okay, so example, car battery. Okay, it's the best example to have a look at. Car battery, number of plates in a electrolyte solution. Okay, especially some of the older car batteries there was a specific battery water that was needed to throw in the battery. Of course, if the solution obviously ran out, just throw some more battery water in there. Of course, nowadays with the newer car batteries, not so much anymore. But basically what we need a battery for is that if we need more energy than one cell can provide. Okay, for example, a mouse, you only need one battery or one cell, but in actual fact with the remote control you need two of them. Alright, so you need more than that, so then obviously you need batteries and not just one cell or one of those little Duracells or Energizer batteries. You need two of them, which you need more energy. The remote can't be powered by one. Some remotes can, depending on the nature of how the remote is structured. Okay, some wireless mice cannot be powered by one battery. Has to be powered by two as well. So if you need more, you just add more, depending on the type of device you are busy working with, of course. Alright, cool. And that's basically how electric cells are used as energy systems. Okay, in a nutshell. There's one thing I want to explain quickly, just for your interest, that a car battery is made up of a group of wet cells. The electrolyte that they contain is sulfuric acid, and the plates are lead peroxide as well as lead sulfate. So take note of the type of acid that is used as an electrolyte, and take note of the type of metals that are used in the plates, lead peroxide or lead sulfate. The cells, which most people just call batteries, they are used in torches, alright, which is another thing I forgot to mention, wireless mouses, electrical toys. They are called dry cells. Okay, so if you buy a pack of batteries, if you take one out, it's only a cell, but although people do refer to them as batteries though. However, in the car battery, the electrolyte inside them, sorry, not in a car battery, in these normal dry cells, is the electrolyte inside them is a paste instead of a liquid. Okay, it's not a liquid, but it's a paste. Now, if you've ever had like a paste before, you'd know it's quite thick. Okay, now the paste makes them safer and easier to use. So it's still moist, but it's a paste. It's like it's a thicker mixture. Whereas in a car battery, it's actually just liquid. All right, it's actual acid used, sulfuric acid as the electrolyte. Hope you all understand the difference. That's not examinable. That's just me telling you what's inside the normal battery. And I think when the battery goes flat, one of those little Duracells or whatever batteries that's used in like everyday appliances or devices, if it goes flat, I think the paste inside it becomes a little bit harder. Because what happens, we took a flat battery, a couple of boys at my school, and we kind of cut it open with a scissor, and it was the substance inside was quite hard. It was like you could break it off into like powdery like substance. So that the paste was no longer moist. It was very dry. It was actually very dry. So I think that's what happens when the battery goes flat, when there's no energy can be supplied, is that it's actually dry on the inside. I think I stand corrected. I'm only speaking from what happened when we cut that little battery open to see what happened on the inside. Alright, just one more thing I'd like to just maybe mention just as a little fun activity. I'm sure everybody has access to a lemon at home. a small light bulb which you can buy at any hardware store, and a paper clip, as well as any connecting wire which you can also get at any hardware electrical store, and a metal plate, maybe like a copper metal plate. If you do that and you have those, let me see, 1, 2, 3, 4, 5 things, which is a metal paper clip, a copper plate, a light bulb. You could also use a multimeter or a voltmeter. You got about 2 20-centimeter strips of copper wire, and also a lemon. You can actually induce a current and cause the light bulb to actually light up, because of the fact that the lemon is being used as a cell or power source. All right, it actually provides power and does actually light up the light bulb. Okay, it's a very nice experiment that you all can do and all can try. I'll give you the steps a little bit later on in our little WhatsApp group, and then you're welcome to try and see if it works. All right, you have holiday time now, so only welcome to give it a shot and give it a go if you'd like to experience an experiment. Thank you so much, Great Nice, for joining me this evening, and we will see each other next week. We will continue with electricity, rather, and we will go on to resistance.